So we have a formula for a circle, and what I want you to understand is if we draw a circle, there's really two things that we need for that circle. Okay, did my best. Did my best. I'm going to center this circle at 0, 0. Okay, and in order to draw a circle, I need its center. And then what else would I need to know about it? Okay, it's x-intercept, y-intercept, or its length of radius, right? Would you agree that this is the length of its radius? So that's r, and this coordinate right here is x, y, correct? Well, if you notice, just like the distance formula that we did yesterday, we can construct a triangle out of this as well. A triangle with a right angle. What is this length right here? What's this length right here? So therefore, if the center is 0, 0, the formula for a circle is simply x squared plus y squared is r squared. Now, if we were to shift that circle, instead of the center being at 0, 0, we'll say the center is at HK. Then the formula becomes x minus h quantity squared plus y minus k quantity squared is equal to r squared. So let's give this a little bit of practice here, and um, we're just gonna do a few examples together, and then you're gonna try a few problems on your own on a scratch sheet of paper, and you'll have your assignment. That'll be it. So the two things we need to identify when we see an equation for a circle is the center of the circle and the radius. What is the center of that circle? 0, 0. Because there's nothing in here for the x's and y's that shifted. Whereas here, there's some shifting happening, isn't there? So the center is 0, 0. Now, be very careful. The equation says r squared. So if this is r squared, this is r squared, what is the radius then? The radius is 3. So it's not this number, it's the square root of that number. You see that? So as I graph this, I'm just going to go over 3 units in each direction. Well, it's really challenging to draw a good circle. No, oh, that's my best. Now, we need to be very careful for the second one. Notice that x minus h produces a center of h, and y minus k produces a center of k. So what do you think the center is for this? It is 4, 3. What mistake do you think people would make as they identify the center? -4, -3, right? if the center was -4, -3, then the equation would look like this. X plus 4 quantity squared plus y plus 3 quantity squared is equal to 49. That would have a center of -4, -3. So it's opposite of what you see. Everybody okay with that? So then what I need is I need the radius. What is the radius? Over 3. Over 4, down 3. And then we go 7 units in each direction. So I guess if I go 7 over, that would bring me to 11. 7 up, that would bring me to 4. Oh, whoop. Thank you. Okay. Over 4 and up 3. My bad. Not negative. Go over to 11. Go up 7, 10. Back to -3. Down to -4. Doesn't have to be exact, but should look reasonable. What do you think? Is that okay? So this is a new piece for you, right? Haven't seen circles yet. Okay. So now, instead of identifying the center and the radius and graphing it, what we're going to do is we're going to write an equation that satisfies it. So it says center at 4, -6. So remember, it's x minus h quantity squared plus y minus k quantity squared is equal to r squared. I have h, I have k, and I have r. So what's the first part going to look like? Good. And how about the second part? Good. Y plus 6 quantity squared is equal to 100. And that's the equation for the circle that has a center at 4, -6 and a radius of 10. How about if the center is at 3, 0? -3, 0. What's the first part going to be? And then just be a y squared, right? You don't have to do y plus 0. You don't have to do y minus 0. You can just write y squared is equal to. Now this is where it gets a little complicated, huh? So we're going to take 2 roots of 6, and we have to square that, right? What does it mean to square something? Multiply by itself. So 2 roots of 6 times 2 roots of 6. 4 times the square root of 36. What's the square root of 36? 6. So 4 times 6 is 24. So this is your equation for your circle that has that center and that radius. What do you think? Okay, so it's a new piece, but we need to be able to look at the equation, identify the center of the radius and graph it, and be able to look at these pieces and be able to identify the equation. Think we can do that? Okay, all right, I'll give you your assignment. Anybody watches the YouTube video, there's our assignment. Notice the change for 87 and 88. Those answers will not match up in the back of your book, but we'll give them to you later.